Hi guys, welcome back to another video. I believe this is lesson 6 of me teaching myself microcontrollers. So if you don't know already, I am working for a company called Matrix now, and they basically make educational kits. I'll show you their website here. So they make a bunch of educational kits and for colleges and universities, and the one that I'm going through is microcontrollers. And so they have their own curriculum, which is 101 page curriculum, and it's called My Introduction to Microcontroller Programming. And so I'm going through this now. So this is what the PDF looks like. So I've done 5 videos already on this. Yeah, I believe this is the 6th. So the exciting thing is I believe we're making a microwave now. Obviously not literally making a microwave, but hopefully in the code. So the company also has their own IDE software called Flowcode, so that's what I'm using to program these. So example 6, binary logic in control. So the last one we did was a binary adder. I quite enjoyed that. It didn't quite work. Most of these lessons have been a bit buggy, so hopefully this one is not buggy, but yeah. All right, so electronic systems can make decisions. Very often these are of the form, if this and this is true, then, or if this or this is true. So we're talking about and or logic. All right, skip all of that. Controlling a microwave oven. For reasons of safety, a microwave oven has a door sensor to make sure that the microwave generator will not operate if the door is open. Put another way, the generator operates if the door is closed and one of the heating control switches is pressed. We can build this condition into a flowcode program. Launch flowcode with a new flowchart. Create the flowchart shown opposite. It uses a loop icon, 2 input icons, 3 output icons, 2 decision icons, 2 calculator icons, a delay icon, and create 4 variables: door, control, output, and count. So nice and easy. I like that. That is just a nice simple setup for a program. They've told me what they want me to do, so now I can just do it. So if we just delete all of this, and what are we doing? So we've got a while loop, and we're saying, I believe it's the decision. I don't know what, I'm not very comfortable with flowcharts yet, so get this full screen actually. So decision, nope, that's what I expected the decision to look like. What does an output look like? Is that an output? No, that can't be. That doesn't make sense. If it's an output, you just drive the door and the control. No. So decision. What was the other thing they said? Calculation. Nope, it's not a calculation. I mean, that looks like an output. Am I wrong? A loop, 2 inputs, 3 outputs. So it could be an input, maybe, I guess. Okay, so inputs and outputs look the same. That's slightly confusing. So we've got 3 inputs, a calculation, and then we have a decision to make. And then, so from that decision, we then, what is this? Is these outputs? I don't understand the color scheme. I'm guessing these red burgundies are inputs, and these blues are outputs. But you got a calculation again, so I don't know. All right, let's do an output. Okay, we got an output, and then let's do a calculation, and then I guess another decision, which is ultimately just an if statement, and then a delay. And what's this? No calculation there. Assume that's an output, and then the end. Okay, so that looks like that, I think. No, inputs, calculation, and then I've got an extra one there. Delete that. All right, cool. So we've got 3 inputs. No, we've got 2 inputs. Let's make up. So that's, we've got the layout now of our code, and I mean that's the pretty cool thing about flow charts, that if you was programming in any other language, would you do that? Would you write out the outline of the functions first, and sort out all the assignments, like put templates for if statements? You wouldn't, in it really. So that's pretty cool that I can just basically quickly write that now. I'll close all of this, and then I can compare literally with a side-by-side sort of thing. That's that code. does that code look like that code? 1, 2, 3, decision, output. Yeah, I'm not familiar yet with, so that's wrong, right? You can see there, that's not meant to be there. Boom, boom, yeah, sorted. Cool, so that makes me happy. That's quite a pleasurable experience. So let's do the 4 variables. So we got door. So I don't know, Project Explorer there, variables. So I need to make some variables. Okay, I've got some here already, so let's replace those. So we've got door to store the state of the switch. That's going to be a Boolean, we assume. They didn't tell us though. Control to store the state of on off. So that's going to be a Boolean again. And then we've got output to control whether the microwave switches on or off or not. So again, that can be so output can be a bool as well, digital output. And then we got count to monitor how many times the 1 second delay has occurred. Give it initial value of 10, so that the microwave will operate for 9 seconds. Count to monitor how many times the 1 second delay has occurred. I don't understand what I read there, but that's fine. We just add a new variable and call it count. And we're going to go with an integer and give it an initial value of 10. All right. Configure one output. Use the default configuration for the loop icon. Configure one output icon to store the state of the door switch on port A bit 0. The state of the door switch. So that's that door variable there. Can I drag that? That would have been nice if I could have dragged that on top. So I believe what they're asking us to do here is to take this door. Oh, but they already showed us the code further up, didn't they? So that goes to door. And then when I don't believe we're writing the whole port, what we're doing is we're writing just one. We're writing just one bit of it. So bit, did you say bit 0? Yeah. A bit 0. And then that now should write that one bit to that variable. So there was, yeah, if I just follow this picture, so A0 to door, that's correct. A1 to control. Okay. So we do control, and we're doing port A, but it's just the bit port A bit 1, which is, in case it's the first video you guys are watching, I'll show you this port. So this is the main microcontroller board, and then you've got ports A, B, C, D, E, and then port A is this top port at the top here. And so bit 0 on port A will be this input switch. Bit 1 will be that one. Bit 7 will be that one. Yeah. Alright, so we've got A1 control. What do we need now? Output is equal to control and door. So we're adding them together. So the output is equal to control plus door. Nice and simple. That's simple. So if the output is 1, this is cool. Oof. I'm having fun, people. We're coding. If the output, can I just say the output is true and just leave it at that? That should work, right? If output. That should work like that. If output. Maybe that does work. Let's try it. So he's written if output is equal to 1. I'm going to write if output. And that, as it's a bit, that should work. So turn off B0 on the null. So we're going to say B0. So port B, and then we want a single bit 0 is equal to 0. And B0 is 1 then there. So port B, single bit, and equal to 1. That's us writing to that. And what's our calculation? And then decrement counter. So I would like to actually decrement. So can I just do count minus minus? Or minus minus count? Damn. Count is minus equals 1. No, not having it. Alright. Count is equal to count minus 1. Okay. And then if count is equal to 0. So again, I'm going to do if it's equal to 0, that's a bit works. Swap yes or no, interesting. Missing. Okay, count, yeah. If count is equal to 0, bit of reverse logic there. That should be the other way around. We swap that. That should be other around. Turn off. So B0 is equal. What was it? Port B and bit 0. So write 0 to B0 and then delay for 1 second. Alright, I've just written this code and I'm comfortable with the code, although I'm not sure what's happening. So we're saying if read the door value. Tell me if the door's open. Read the door value. Read the control value, meaning if you'd ask me to heat up. And if the door is closed and you're asking me to heat up, if that's true, then turn on B0, which you don't know what it is. Let's say the generator inside the microwave. I think that's what he said, right? He said the generator inside the microwave. I think that was a term that was used, which I'm not sure. Yeah. Put another way, the generator operates the door. The generator operates if the door is closed. So yeah, I'm not sure what we're referring to there. But so if the door's closed and you're asking it to heat up, then output turn on the generator or whatever, and then start decreasing the count timer. If your count's not finished, then once your count timer runs out and it equals 0, meaning you've done this 10 times, then turn off the output and wait 1 second before starting all over again. Okay. I'm happy with that. Okay, so configure the other input icon to store the state of the control switch. Yep, the upper calculation icon checks to see whether the door and the control switch has been pressed. Configure it using the equation, blah, blah, blah. Oh, the upper decision icon checks the value stored in output. If output 0 is shorthand for if the output is 1. Nice. It does accept the shorthand. I like that. I like that. Can I highlight that green? I like that. Give that a green highlight. That's cool. So when the result of the calculation is 0, the program follows the no root, blah blah blah. The lower calculation icon reduces the number stored in the variable count by 1. The initial value of count is 10, provided the number stored in count has not reached 0. The program follows the no root. Eventually, after looping enough times, the number stored does reduce to 0. The program then follows the yes root and executes a turn off output, which is configured in the same way as turn off icon, switch, blah blah blah. Add a switch array to the system panel. I'm not going to do that. It's kind of interesting switch actually. Maybe I will. Add a switch array to the system panel. Configure it to only have 2 switches. One connected to port A, bit 0, blah blah. Add an LED connected to port B. Add labels. Now simulate the program. Why are we simulating again? Check what happens for different combinations of switch states and interpret this in terms of behavior. So I'm going to go straight for a full download because why are we simulating? I don't want to be simulating, you know what I mean? I didn't pay for this hardware, but if I did pay for the hardware, I'd want to be using it. So let's sort our ports out. So the ports are kind of sorted, so this should just work. So compile. I say this works. And if it does, this will be the smoothest EBlocks lesson and video I've done. Please just don't give me any issues, just work. Okay, so what are we saying here? We're saying A0 and A1. So if I press anything happening? No. Anything happening? So I pressed one or the other, nothing happens. This is A0 and A1. Press them both. Anything? You bugger. Nothing. So press them both. Nilch. Alright. Are these A? They're not A0. This is 0 and 1. Okay, let's just have a look through the code. So it's probably best to just simulate it to make sure I'm not going crazy. So it's control and door there. You see, I'm a Dumbo. Obviously, I know why. I was stupidly just whizzing through filling that out. Yep. See, I did say it was obvious that I was a Dumbo. And door. Ah, we get there in the end, huh? All right. Give me this 2D panel back again. And let me just see it working. So my door is, so this is wrong for sure. My door output is still set to true right now. And wait, what? It says 1. To make that make sense, I hover over it. It says bool door is equal to 0. Okay, so if I turn on whichever one it is, that's the door. So that should now be on now. But again, we're not decrementing. Turn on the control. Interesting that the door then turned off to 0. Turn them both on. Okay, we've got an output of 1. Turn 1 off. The output should go back to 0. Output does. Alright, so that's working correctly now. It's just me being a dumbo. Alright, let's build. So stop the simulation. Build it to our real hardware and just make a nice simple. Can I ever just get a nice simple control? Come on. This is easy programming, man. And I'm struggling. Alright. So press 1, nothing. Press the other one, nothing. Press both together, nothing. Why? I definitely got both the inputs on because you can see them there. So why nothing? If I press them both down, then that should turn on for 10 seconds. If the output's equal to 1, yes, write 1 to B0. So why is B0 not working? Okay, so a bit of troubleshooting here. Is this correct? This output 0 B0. So if I just copy and paste that and just do that right in the beginning, will that turn on? I would love a video, honestly, where I just go through the curriculum and it just works and I get it right the first time and the video is 5 minutes. I don't know why these videos have to be 20 minutes. It's infuriating. So now I've just set that output. I've set it to 0. Oh, look at it. Look at it. Set it to 0. Oh, man. Set it to 1, you dumbo. Oh, my gosh. 1. Set the output to 1. So what have I done wrong there then? If it's true, why is that 0? It says if it's true, turn off. Otherwise, keep it on. That's what the code says. So if I can just grab another loop, that's why. It's, again, bad code. It's always bad code. So I'm just going to enter that loop there, and I just want that output to turn on. Just turn on for me. That LED, bottom right, port B, bit 0, turn on. Keep it simple. And it's not. Why is that not turning on? Okay, so we have a different issue here. That output B0 is not working. So port B, single bit. Alright, so let's just, can I just turn on the entire port then? And just confirm that does anything work? No? No? Really? Nothing. You're telling me that's not gonna turn on? Reset. Set the power out. What on earth, mate? Okay, let's run it in simulation to make sure I expect it to go into this while loop and stay there. Yeah. So why is that not turning on? Deary me's, mate. I must say, this doesn't feel like I'm learning much. It feels more like I'm kind of troubleshooting Flowcode and learning how to read. Why? Okay. So right now, all those LEDs should be on. And none of them are. Alright, let's go full Duke Nukem mode, yeah? So this whole bit of code, I think I saw someone toggle disable. Oh damn, not all of that. This bit of code is disabled. That's commented out now. So this bit here, get rid of that loop. So just to confirm, if I run this, it just jumps out straight away. Yeah. So make sure I'm not crazy. Compile to target. Hey, this is painful, man. This is painful. I've just like lost the ability to turn on an output. Mate, what happened? What happened? What I did was, just to make sure I wasn't going nuts, I went and loaded up the old LCD program, which is like the stopwatch one, and that again didn't do anything. Does this put an I mean, this whole experience has been pretty painful, to be honest. Does this put an end to my EBlocks? I mean, I guess I could just run stuff in simulation, right? Yeah. All right, let's quickly spin up a simulation. So I just got to bring all this code back in. Actually, I thought I was going nuts. So bring all this code back in, bring up my 2D panel, and then debug. All right, so run, and then that should run a bit fast. All right, cool. So we're ticking through this program on the left here. We're checking to see if our door or our controller's on. Why don't I have the okay, there. So we can see that apparently my door's on, which is weird. It says 1, but press the door one. That's now true, but still the LED's not on, and the program's still going through no. I turn that one off and put that one on. Still no, and then turn them both on. Still no. Still no. Huh? Oh, okay. I got this bit of code in that I got to get rid of, I think. That port. Alright, let's run that. So no. Turn that one on. No. Both on. Yes. Both on. Yes. Okay. So now this is working correctly. Yeah. I mean, it is what it is, isn't it? I mean, it looks to me like the board is buggered. We'll try. We'll try one more time for good measure. But yeah. Otherwise, it's gonna have to be a thank you for watching, guys, and I don't know if there'll be another video. Oh dear. All right. Yeah. I'll probably just finish this off and do the simulations. But I'm a hardware. I want to use the real hardware. I don't want to do simulation. All right. So this input. All right. Why is the else? Right. So the 7-segment display is lighting up right now, which is fine. It works now. Oh, do one, mate, man. Bloody hell. I would have been happier and I would have been able to sleep better if that didn't work. So there's 2 switches here. 7-segment display. Oh, sorry, you guys can't see. 7-segment display switch here. So I'll turn that one off. So that way it doesn't turn on the 7-segment displays. So there's my 2 inputs. Press them both on and then the bloody output comes on. And it works. Individually, nothing. Both of them turns on. You can see that, right? How long has this video been? Another 20 minutes. Alright, anyways, thanks for watching, guys. I don't understand. I mean, obviously, this code, I get this code. This code is easy, it works. It's my fault for being dumb and saying output is equal to control plus door instead of doing output is equal to control and door. So yeah, difference between or and and. But yeah, I don't understand why the hardware bugged there and didn't work and now it did work, and yeah, I don't know what happened there. So thanks for watching, guys. I'm a bit frustrated with all of this, but yeah, we'll just continue on. So the next one is binary logic inside a car, which again, that just looks extremely simple again. So yeah, hopefully the next video will be 2 minutes, not 25. Sorry. Take care. Bye bye.